Assalamualaikum and good morning to fellow panel, Dr. Khairul Anwar bin Ibrahim and TS Asri bin Din. In this video, I'm MOHAMAD FAZLI bin USIN from 4 BEEI FTKEE student would like to present about my bachelor degree project entitled Energy Storage System of Regenerative Braking in Urban Railway based on Supercapacitor. So for the project description, energy storage system of regenerative braking in urban railway based on supercapacitor is a project that focuses on using supercapacitor as energy storage system in order to store and recycle waste energy by regenerative braking in urban electrification railway. Besides decreasing energy consumption, utilizing and regenerative power is one of the most effective way to save energy. So for the introduction, rail transport is arguably one of the most efficient methods for mass transportation of passengers. This makes it a popular choice for satisfying increasing transport demand in an environmental concerned economy. Besides, with the growing renewable sustained energy, the demand of electrical transportation system is increasing because of this system prevent environmental pollution, also reduction of energy consumption and CO2 emission, and electrical is cheap compared to fossil fuel. When the train stop, it produces high voltage motor, also high amount of braking energy is produced. When a train is operating in powering mode, it will consume power from wayside power substation or onboard power supply. In urban railway operation, energy saving operation can be achieved by reducing energy consumption and increasing energy usage, increasing regenerative energy usage. So for the supercapacitor is an energy storage technology that rapidly developing and being implemented in various industrial applications. Some electrical rail transportation system use supercapacitor for voltage enhancement and recuperation of regenerative braking energy. So why I'm using supercapacitor? This energy is not new and already being used by many developed countries like Europe, Germany, China, Japan, and many more, but not in Malaysia. So because of unlimited cycle life, high spec power, low resistance, enable high load current, and the most important thing, charge in second, save long lifetime. It can reach 20 years and less maintenance and many more. Next, for the problem statement, the project want to tackle energy wasted that produced by regenerative braking in electrification train. During regenerative train braking, the kinetic energy of the train is converted to electricity that can be used or transferred to another system when needed. This is compared to other conventional brake, which is the kinetic energy converted to heat and wasted to the environment. As an urban rail transit, this railway system needs frequent start-up and braking. Traction power supply substation cannot absorb energy in reverse direction. The excess energy generated during regenerative braking cannot be reused, resulting in energy wasted. Alright, next for the objective. First, to develop the effective energy management for reduction of energy waste and consumption on urban railway. Second, to investigate and study the behavior and characteristic of supercapacitor. And lastly, to design the simulation modeling of energy storage system using supercapacitor. Okay, now for the methodology of this project, based on the first flowchart, this project started with the analysis of actual energy consumption. So since this project based on Malaysia electrification trend, so railway electrification in Malaysia started on 3rd August 1995, that the first electric railway service, the KTM commuter, began operation. The KTM ETS, also known as Electric Train Service, is an intercity rail passenger service operated by Kereta Api Tanah Melayu KTM using electric multiple unit EMU. So the KTM ETS is the second electric train service to be operated by the Malaysia Railway Company. So one of the train that using regenerative braking system in Malaysia is the KTM Class 93 model that started operation on 3rd September 2015. Then for the railway power supply system, the Class 93 train use traction power distribution system and powered by electricity from the catenary overhead line. An overhead line consists of one or more wire over rail track raised to a high electrical potential by connecting to feeder station at regular intervals, and then the feeder station are usually fed from a high voltage electrical grid. Next, the recuperation of regenerative braking. This Class 93 model use regenerative braking system as its braking system. The conversion of kinetic energy into electric, commonly known as dynamic braking, is based on the capacity of electric motor to also act as generator. In contrast to friction braking, it does not generate wear, tear, dust, smell or sound, but with current technology, regenerative braking appear to be a very promising solution to reduce energy consumption in electric urban transport network. So from this regenerative braking, what system that I use to prevent the waste of braking energy? So I will use onboard energy storage system. The outstanding advance in both power electronic and energy storage technology have enabled energy storage system to become an excellent option for using regenerative braking energy in urban railway. Onboard energy storage system permit rail vehicles to temporarily to store their own braking energy and reutilize it in the acceleration phase or other. So where I want to store the wasted energy, so the best way to deal with regenerative braking energy is to store energy in supercapacitor, the double layer ECDL capacitor. So the reason I'm choosing supercapacitor because of the long time, lower size, weight, easy to control, easy to calculate the state of charge of element and others. First, the concept of energy storage is emerging as a solution to energy management, energy saving, and perform improvement for power system. For the circuit modeling, in order to achieve better energy saving effect of the supercapacitor energy storage system, an online optimization control strategy is proposed in this modeling scope. The modeling of the system is essential to simulate the real system on computer using computer software. So I'm using MATLAB software. It provides a user-friendly interfacing that allow the user to model and edit the project easily. Okay, this is my full circuit diagram, and this is my flowchart of the circuit. And for the flowchart, the PMW will generate signal when the signal is received Battery and supercapacitor is charged by power supply until certain limit. Maximum limit goes to 100% and the minimum value at least 90%. Then lastly, it will plot a graph of current demand, voltage, SOC, state of charge. The power output will be measured and graphed and performed accordingly. Okay, for the circuit simulation, I will do the comparison with the other storage system, that is battery, to prove that supercapacitor have more advantages, and I will explain more on my demonstration video later. From the circuit simulation, I will display current, voltage, the SOC, and the power output for both energy storage, supercapacitor and battery, and I will explain more detail later. As for the conclusion, the rapid advancement in the power electronic technology today has allowed us to explore the benefit of supercapacitor as energy storage element that provide advantage in many ways apart from battery, such as the energy storage deterioration. So for the simulation result, MATLAB Simulink perform the ideal result for the charging and discharging rate of current, voltage, the state of charge, which occurred in the charging and discharging process. This is my overall design of circuit simulation. Although it looks easy and simple, but if we convert it into hardware, we already get complete energy storage system. The energy storage was simulated on the basic of the parameter of energy storage itself, battery, here battery and supercapacitor. So for the battery, I'm using lithium ion 30 volt type, and for the supercapacitor, I'm using 16 volt 500 farad model. Then supercapacitor and battery is charged by 42 volt DC supply, which are connected to buck boost converter and boost converter respectively. The resultant output of simulation is analyzed for 600 seconds to obtain the SOC voltage current output of the battery and supercapacitor. The power supply gives power to charge the battery. During the discharge condition, the battery may discharge through a supercapacitor, so the current demand will be smoother. Furthermore, this simulation is comparing between charge and discharge condition of supercapacitor along with battery performance. The switch is triggered by pulse within modulation. To switch on the supercapacitor, switch on the both circuit. When boost converter is on, the supercapacitor is on charging state. So now before we run the simulation, we need to set it normal and we run it and wait until it finish compile. Now we already finished compile, so to display the result, here we need to press the scope 1, scope 2 and scope 3. Now this is the result. For the scope 1 here battery and the scope 2 is supercapacitor. So for the scope 1 battery show that the battery, when there is current charge up, the battery will charging until 100% and slightly decrease once there is no more current supply for charging situation. The battery provides nearly constant voltage and current is discharged only nearly about 40% during this performance. So for panel information, the SOC for the charging and the current for the discharging result. So for the supercapacitor, it charging nearly 95% and slightly decrease once there is no more current supply for the charging situation. And for the discharging, it discharge 100% completely compared to battery only 40%. And it voltage drop, but at the initial time it provide very high current. The supercapacitor start to discharge over time until it reach zero. Okay, for the power output. Show that the supercapacitor provide peak power for short duration and decrease to zero, but battery provide constant power for longer time. The power output of supercapacitor is very high compared to battery. So if we look to the SOC, the battery SOC decrease slowly at the relative stable level, while the supercapacitor SOC change dramatically. So from there we know that supercapacitor store and discharge faster than battery. Since the current of supercapacitor drop with their operation voltage, but battery provide constant current, and increase in the size of the supercapacitor module lead to an improvement of the power system efficiency lead. So the simulation revealed the difference of battery and the supercapacitor in nature. Supercapacitor is used to provide high peak power, but its energy density is lower. For battery, has higher energy density, but its power density is lower. So lastly, based on the simulation result, comparing the supercapacitor with a battery has its own merit. So the capacitor is non-electrochemical, and the maximum voltage is determined by the type of the electric material used as separator between the plate. The presence of electrolyte in some capacitor boosts the capacitance, and this may cause confusion. Since the supercapacitor is non-chemical, the voltage is free to rise until the electric fails. This is often in the form of a short circuit, avoid going higher than the specific voltage. So that's all for my presentation. Thank you.